Hello, everybody. My name is Krasimir Kostadinov. I'm CTO of Scalefocus. Tonight, we are here with Dimitar Elenkov, technology team lead in our company, and we'll discuss the topics of platform engineering and minimal viable cloud. And first of all, what's minimal viable cloud? Maybe we should get some clarity on the terms first and foremost before discussing them at further length.
All right. So, what behind the minimal viable cloud? Actually, this is the solution, a minimalistic one that is capable to provide needed infrastructure services for a dedicated application. Only the needed one. And it also provides automation approach to autoscale after that and to give to developers the availability to work on needed infrastructure stuff, to develop on them. Yeah?
Yeah, and I might add to that description is basically the minimal viability concept.
Yeah.
And it comes into terms as minimal viable architecture, minimal viable product, and so on.
Right,
basically, the idea of don't do what you don't have to do for your product to reach the market and to have validated hypotheses through real customers.
Yeah.
Instead of engineering the next Netflix and then realizing that there is no market and no real customers for it.
That's the thing, that if you need to evaluate your idea, like a kind of startup, then it's good to start with something small and after to grow. And here the MVC is something that will be really helpful.
And another aspect is probably it's quite easy to over-provision in cloud.
Yeah.
More so than over-provisioning on local infrastructure. So it's a good approach to think of what you don't need instead of what you need.
Yeah, for sure.
And on the other hand, the other topic and then the interplay of the two, what is platform engineering?
Yeah, this is, some kind of hype now, let's say.
Yeah.
But what gives platform engineering is actually with that kind of service or approach, you can give to developers the opportunity to focus only to produce code and not to dealing with configuration management, infrastructure as a code stuffs, and all other things that, let's say, developers don't like. So that means that the platform engineering gives actually workflows and tool chains which incorporated everything that is needed to provide it to the developers, so-called self-service opportunities to, let's say, the most important, the component that is really important in the platform engineering. This is the IDP, or internal development portal, where you can actually go and request some kind of infrastructure in the cloud from service catalogs, and everything is there. So you just don't need to dealing with any other stuff. You just request it, it's approved from somebody from the platform team, and after that you start working on it.
So basically, instead of relying on your DevOps engineer that's part of your team, you go into some kind of a web portal and provision whatever you need. Yeah,
there is a self-service portal that provides for you all the so-called service catalogs. Service catalogs actually, back in the days, and now the ITIL service catalogs are something similar, but they are providing functionalities to the OIT teams. But the service catalogs in the IDP actually provide that for the developers in the company. So we started to treat them like internal customers,
So basically the DevOps engineers, instead of provisioning whatever everyone needs, are actually focusing some of their time on developing the internal developer platform.
Yeah.
And everybody that needs some kind of a infrastructure, for example, PostgreSQL database, for example, they can go and provision that for themselves and work with it immediately. Okay.
Yeah.
And indeed, it's quite the hype, by the way. I can attest to that. We see that there are some questions in the live stream, so after we conclude our discussion, we'll welcome all of you to actually contribute to the discussion and ask your questions. We'll collect them together and answer them in the Q&A section. So what's the interplay of minimal viable cloud and platform engineering? How do they come together?
It's again back to the previous discussion. Actually, the minimal viable cloud, as we defined, is a kind of infrastructure, cloud infrastructure services architecture, core startup stack or something that you can actually leverage by the IDP when you are actually, or the developer requests a service catalog which produce the MVC, and they can, or he or she, or they can start working on it. Yeah, and also you can provide with the platform engineering and the whole functionalities inside. After that, additional features to scale this MVC to next level when they need it for that.
My understanding, or at least another approach, is minimal viable cloud, from my perspective, requires discipline. Basically, for you to not do whatever you don't need and not support what you don't need immediately. And platform engineering becoming some kind of a gatekeeper to the resources can enforce that discipline on the development teams instead of relying basically to follow the best practices of minimal viable cloud, but provision whatever they want without supervision or approval.
It's a kind of learning curve for developers.
So another important question is, and that comes back to the hype that's been recently. Probably many of you have seen the memes online of platform engineering standing on the grave of DevOps. So what do you think? Is platform engineering going to supersede or be the end or the death of DevOps?
Actually, as we discussed, we see that there is a connection between DevOps processes or the whole culture and the platform engineering, because actually the platform engineering, it's upgrading or it's enhancing the DevOps processes in the company. So it means that the DevOps also would be something that would be important for the companies, and platform engineers actually will give more possibilities to make the things right.
But then again, if we keep, and that's a question that probably many stakeholders, business stakeholders have, if I keep my DevOps teams that are part of the development squads or whatever the structure might be, and on the other hand, I have a bunch of other guys that do platform engineering, isn't that an overhead and actually overspend from the company perspective?
It depends a lot how actually a company is able to adopt on first the DevOps practices, and after that, is it makes sense to implement platform engineering. But back to the question, platform engineering use the most of the tool chain that is incorporated in the DevOps. So you can use the same the same people, DevOps engineers, to do the platform work as well, and also to let's say gain more knowledge and to actually expand the roles that they have, you know. So you can think that maybe it's better and a kind of cost-saving approach to make a platform team from engineers. Not platform and DevOps, but a kind of team that incorporated both roles together. Because most of the skills that are needed, we have them right now, you know.
So basically, the idea is you still use your DevOps. They still do whatever they're good at, but the repeatable part of their work, basically they set aside into a platform that everyone can use, and the repeatable part of the DevOps engineers' work goes into that platform where everyone can self-service, basically. Okay. What are the security risks, and are there new security risks when adopting platform engineering, and how can we mitigate them?
So always there is a security risk, you know, but actually what we have here is internal development portal, and it's actually the whole path to be developed is based on the same patterns that are for any kind of other software development processes. That means that it should be compliant with any security policies that are in place. It should be based on the all best practices and patterns that need to be used, and then also to be re-evaluated on a schedule basis. And that means that from that point of view, there's no kind of security risk that is different than for other applications.
Because from another point of view, it's quite crucial to get the security right in platform engineering, because security vulnerabilities might be introduced on quite low level. For example, special users in the databases that are provisioned, or whatever, backdoors.
That's why we have identity management in place, which is part of the whole process.
So basically only certified people have access to the platform, they can contribute. And
we have any kind of cloud natives, because more or less also this is something that is delivered in the cloud, so we can use the cloud native tools there and all the services that providing additional security, you know, like encryption and stuff.
Talking about the cloud services that are provided, there is a natural question that many business leaders probably have about platform engineering, and that is, if we build a platform basically that provisions various stuff, regardless, infrastructure, services, and so on premise, and most of the development work nowadays is done in the cloud. Wouldn't that be just, say, a few years down the line, the cloud providers can just create their own external, because it's not internal for them, but external developer platforms that can just, the developers will log in with different credentials and actually provision whatever they need the same way as in the IDP internally?
Yeah, this is really good question and something that may happen, but actually we can think for the cloud currently as a kind of platform IDPs as well, you know, I mean platform engineering services. On the other hand, of course, there are some custom needs for the businesses, so maybe they need to, or not maybe, but in most cases they need to create something that is customizable and it's for their needs and it should be in their premise. And that means that the custom IDPs also should be needed, and the platform engineering should be there. And on the other hand, also from security perspective, you know, maybe a dedicated company need to manage and to keep the whole IDP in a kind of environment that it's not exposed publicly.
And also there is the question of intellectual property, because the IDP is intellectual property of the company that produced it, and it might be a competitive edge for that company and for its development practices, while as a cloud-based IDP is basically no competitive advantage because everyone can benefit from it. And also it's just standard templates that serve everyone, and at the same time no one, because they will be too generic.
Yeah.
Of course, companies can do their own templates, but that basically shifts the whole game. Yeah, we will build our IDP in the cloud, but again, the platform engineers have to build it. So, and there is a tricky question, and actually it can be expanded upon, but where does the job of a DevOps engineer stop, and where does the platform engineering stuff starts? And before you answer, there is another popular title, so to say, site reliability engineer, that's also put in the mix. And where is the distinction between the three?
So I can say that it's not complicated, but there is a kind of confusion, because, you know, let's say the DevOps engineers, they are engaged to provide the whole application lifecycle management process with the continuous delivery tooling and landscape and so on. On the other hand, platform engineers, they need, or they should provide platform as a service and the infrastructure. And the reliability engineers, obviously, they need to keep the reliability of the application. So they actually provide the reliability tooling and infrastructure and monitor it.
So basically, again,
it can be a bit complicated, and actually, let's say one engineer can do more than one, can incorporate it more than one role and responsibilities.
And as I believe, site reliability engineer came out of Google as a role and responsibilities, and they usually are kind of a mash-in of IT ops and DevOps, and they do provide sometimes 24/7 support,
shifting,
pager duty, and so on. While as usually the DevOps engineers and the platform engineers are 8x5, they're working in business hours and so on, and closer with development teams. And it's an important question, by the way. When should a company, because most companies that develop software usually have DevOps engineers, but when should a company start to think about maybe introducing platform engineering? Is it one size fits all? Basically, everyone should have platform engineers. And
it's for all kind of approaches or scenarios or patterns or whatever. Nothing is for everybody, you know. So here again, the platform engineering is something that should be implemented in companies that have, let's say, more than 20 developers or more, and that also were able to adopt it successfully, DevOps culture and processing and GitOps, because then they can use the whole understanding and knowledge that is gained by the years about the tooling and all the needed workflows to be implemented.
And what about site reliability engineers? Because we put them in the mix.
This is, it depends, of course, again, of the needs of the company. But if there is a need for ongoing, continuous monitoring, reliability, some changes that are, provided reliability and stuff, then again, that should be something in place.
So basically, if the need for communication and collaboration, because as the teams grow, so does the Metcalfe's law. Basically, with the second power, the number of communication channels grow, and it's much easier to, at some point, probably more than 30, 40 people develop on teams. It's more efficient to let the teams provision their own infrastructure instead of relying every time on somebody else to provision that.
To be self-hosted, let's say, yeah.
Yes.
In some ways.
Yeah. And again, and that's a natural question stemming from that.
Yeah.
If everyone can provision their own infrastructure, isn't there a threat of over-provisioning?
Of course, but here again, as we said, and in the beginning about the platform engineering, we it's using and established workflows and a tool chain. Of course, there is a self-service portal that actually provided those kind of infrastructure as a code automations incorporating service catalogs. But this is a process that actually is passed in an approval process, you know, and in a review process from a dedicated platform engineer who, before a dedicated infrastructure to be deployed, he approved it. And also again here, because you know something is working now, but in the future maybe it's not sufficient. And I mean from infrastructure perspective for the cloud services. And here is this is so-called established feedback kind of path where actually developers and platform engineers discussed and evaluate what is needed from service catalog perspective.
Are there any statistics done on what's being used by the service catalog?
Yeah. Self-service portals actually provided a lot of statistics, but also you can use other ways in the IDPs where you can integrate such kind of feature. Also, you can check, you can use their feature that will provide you the understanding of the cost that is built in about the cloud services. You can incorporate it with the cloud services because there is out of the box a lot of stuff that you can use, you know.
And how do you, so and that goes back to the monitoring when everybody provisions their own infrastructure, how can you centrally still monitor it?
There are different ways, but you can use, of course, cloud providers to and the tooling that they provided. Like in Azure, you know, there is Azure Monitor for that. You can use application insights. You can use third parties. If let's say if we have a kind of container orchestration engine there, like Azure Kubernetes services, you can use the insights that it's provided like a feature, but you can use, of course, Prometheus with Grafana and stuff, and there's a lot of possibilities for that, you know. And this actually will expose what is used, what if there are some quotas, if the limitation is hit or no.
So it's the job of the portal engineering team not only to work on the internal developer platform, but also to monitor what's being issued by the platform.
There are different planes. The whole internal developer platform actually incorporated different planes, and each plane provide functionalities. Like you have delivery plane with continuous delivery stuff. You have main plane. I forgot the right name, but actually there is the IDP, there is source control stuff, and so on. There is a monitoring plane. There is a state plane also, and stuff. So yeah, and all of this incorporating the same tooling landscape that DevOps is using and introduced 15 years ago to the companies. So,
and what can you give as best practices? Because we mentioned that there is a chain of approval in the internal developer platform or portal, whatever, IDP. So what are the best practices in terms of who approves what? Because especially in cloud, some provisionings might incur a lot of cost. So is it the budget owner? Is it the architect? Is it just the platform engineering team? How does it work?
It depends what kind of service need to be deployed, but in most cases there are POs, product owners, also involved, and also there is a platform engineers that actually provided the catalogs, and before that they communicate to establish the right practices for that, and the whole so you can. There is a proof process, but it depends. I mean, it can be auto-proof for a dedicated service, but the platform engineers, but others need additional approval by notification from a POs or other stakeholders.
And that's done automatically by the IDP.
You can do that.
Okay.
But in most cases, the final approval for something, maybe it's not a good idea to be automated fully, end-to-end. But of course, I forgot something important about the auto-provisioning, about the provisioning. Of course, let's say, for example, in Azure, as a cloud provider, I'm speaking a lot about Azure because this is something that I'm doing mostly. Of course, you can add work attributes to the to all resource groups. So when you work them, and you provide it only specific service principals that have additional permissions to deploy them, nobody else can extend or make changes in the resource groups.
So basically, you can use built-in mechanisms into the cloud to make sure nobody is just bringing up huge clusters of whatever just to try it out. Okay. By the way, you mentioned quite a few, basically name dropped quite a few technologies. Can you maybe elaborate on what are the common technologies that are used, and maybe if you want to weigh in on your opinion on those, but basically, what's the tech stack that is usually used for platform engineering and by extension minimal viable cloud?
Actually, it's overlapping a lot with the DevOps tools landscape. Let's say you have internal developer portals like Backstage is something that is open source, and it's provides a lot of capabilities. You have source controls, any kind of, I mean, you can use Bitbucket or Azure repos or whatever. I mean, it's the same. About the infrastructure as a code part, you can use actually Terraform. You can use Pulumi. Even if you would like, you can use Ansible, because you can do infrastructure as a code deployment, not only configuration management stuff. For monitoring, as I said, Prometheus. There are a lot of Datadogs and stuff, and
and
my opinion, I always would like to use something that is out of the vendor walk-in. That means that it's not domain specific language, that it's based more to the workforce of pure programming, and it's open source. It's not build it with additional licenses.
So your advice would be, even if the cloud providers come up with IDPs of their own, even in that case, you would not advise on using those, because then you're locked even more to that cloud provider.
That's right. And also, actually, in these days now, there is a kind of interesting discussion for multi-cloud setups because of the vendor walk-in, so and because of cost optimization and stuff. So you can use and you can try to evaluate and to use only the services that you needed, basically from everywhere, and incorporate it in a dedicated
That is actually a case for building an internal developer portal or platform, because if you build the platform yourself, you're not depending on any cloud, particular cloud. Also, it's easy to migrate. It's easy to do hybrid cloud, multi-cloud, whatever you need. And that actually gives you flexibility if you need that flexibility, of course.
For sure.
And what would be the path to platform? If you can explain how a company that's currently doing DevOps, what would be the logical steps to start on the path to platform engineering? We mentioned that that's a good practice for bigger development teams, for multiple development teams, but can you just elaborate more on what are basically what should be considered a trigger for building a platform engineering expertise in the company, and what will be the logical steps to go in that direction?
So the logical step would be to start with a pilot project, and firstly to see if you're able, or the company is able to upgrade and to make better the whole DevOps practices, and after to start this pilot project and to add additional components from the platform engineering service and to evaluate it, to see if it's working or no, to gather feedback from the developers, to see if it's all right, if it's not a kind of additional burden on them.
And how do you establish the service catalog? I mean, you can include anything in it. How should you start selecting the right services?
The right services are based on the any kind of cloud native development approach. Actually, it have some patterns, and also the application that need to be developed from a dedicated squad. It has components inside. So, based on these discussions and with them, and the understanding what is needed as a common use, you can create the service catalogs. But those catalogs, they are infrastructure as a code based in most cases. So you can always upgrade them or change them and add additional modules or components or what is needed inside. So
basically start small, scope well, and see
MVC.
How it works. Yeah, use MVC, of course. By the way, you should always, it's a great idea to use the minimal viable strategy in whatever you do. If it's cloud, if it's security, if it's architecture, if it's products, validate small, because otherwise you're pouring money into something that might turn out to be a failure or not viable with the market or so on. Okay, and how does it work in terms of people are just provisioning infrastructure? Actually, engineers are provisioning infrastructure themselves, and then that infrastructure at some point needs to be upgraded, or the code that they operate. How do you go from a development environment to, for example, a test environment, a QE environment, a staging environment, and all that stuff? Who is responsible? For example, does the test environment have to be provisioned by the quality engineers, or how does it work?
It depends what is the adopted strategy in the company. In some cases, so if you have platform engineering, obviously everything should be encapsulated from the platform team and provided to the developers or to QEs or to any kind of engineer that is involved. And here is additional things that need to be implemented, like to have environment, let's say again for cloud provider, for Azure, let's say, you can separate it environments per logical boundaries like resource groups. You can prepare the catalogs to be able to, so they would provide, let's say you would like to request a dedicated service. There is a drop-down menu where you can make your choices, and in some some cases actually provided a prod and non-prod environment together, just deploy them in different resource groups and everything what is needed, or maybe in different subscriptions, it depends. On other, the other option is actually to choose. I want to deploy to QE, but it doesn't make sense to deploy in tests before to deploy in development environment. And after that, maybe you can do that with a pure or a typical continuous delivery approach.
But
to
then
promote the whole.
How do you get established environments then? Because if anyone can provision basically the same infrastructure that, for example, anyone can build up an environment or the whole stack that needs to run the application or the system or whatever, then how do you make that the I don't know, staging environment or environment X that everyone deploys on, or how do you manage the build pipelines so as certain triggers are matched, or for example, somebody merges into a certain branch, how do you make sure that the right environment is selected?
All right, but this is a bit out of the platform engineering scope, because it's more related to the continuous delivery approach. And there you have, of course, pipelines. You have, let's say, in Azure DevOps services, if we can say, we discussed about this. You have a kind of flow that you prepared, and it's predefined with all the triggers for a dedicated environment. Also, you can assign, again, approvals, or who can be able even to you know, to review and to close a pull request that can actually trigger a CI, and after that this CI to produce artifact, this artifact to go to a dedicated, maybe in registry or no, and to deploy and to trigger the CD for that. And there is separation per environments, but no, in most cases, not everybody can do the continuous deployment part. And also you can incorporate this with, let's say, in container orchestration platform like OpenShift. You know, you can use inside, there is tools for that, and you can incorporate GitOps approach for that, you know. And it's, but I mean, this is a bit more, this is the more related to the role of DevOps, not so much to the platform engineers, because they provide the service catalogs that actually deliver the infrastructure part.
So basically the setup is anyone can provision at least part of the services from the service catalog, but again, the DevOps guys and girls have to actually make sure that the continuous deployment is happening on the right environments that everyone should use, and so on, and that they are monitored. Because some environments have different needs in terms of monitoring from others.
This is one of the most important values of the DevOps, that there is a feedback from the delivery, and it's ongoing. When you deliver something, you get the feedback from the client or from the customer or from the resource with the health checks and stuff, and you know what is going on. If this is delivered successfully, if there are some issues that need to be fixed. And there is release engineers also, you know, which also is another role that incorporated maybe in the whole ecosystem of people. That
an important point should be made here, that all those roles that we mentioned, like site reliability engineers, release engineers, release train conductors, whatever, everything but the DevOps role should be considered only when the complexity and the size of the development force grows beyond a certain point, because and that goes back to the minimal viability concept. What I've seen throughout my career so far in various customers and so on, is that too many companies try to emulate the big guys. You know, the Amazons, the Netflixes, the Spotifys, whatever. And the important point here is Spotify has such architecture and such development practices because they're resolving the problems that Spotify has.
Yeah, for
If
sure.
you don't have the problems that Spotify has, don't just copy practices from Google, from Spotify, from Netflix. Netflix's architecture was quite copied for a while. It solves a specific problem. And on the other hand, practices such as site reliability engineering, which Google has a need for.
Yeah.
But do you have the same needs as Google?
Yeah.
Which is the question you should first ask, because those roles are quite helpful and they do bring value, but only if you have certain problems that they resolve.
Of course.
And that's an important part. First, assess your needs and see whether those roles will actually resolve issues that you have.
Yeah, for sure. It's always like this with everything that actually is in our world of development and delivery of software, you know.
Yeah.
You need to assess something before to start doing it and just incorporate it from somewhere, something that everybody says that is good, but
a lot of teams, for example, and from what I've seen, for example, taking Spotify as an example, the Spotify squads were quite copied for a while.
yeah,
They do bring value, but you need to have certain architecture, certain set of problems, certain size for those practices to actually bring benefit and not just overhead and hassle and so on.
for sure.
What is your thought on actually the monolithic approach of delivering software versus splitting the software early on through those practices that we mentioned? And
So
yeah,
as we started with the MVC, actually this is maybe the best approach is to use a monolithic pattern for application, to evaluate it, to see if it's working, if it's for you, if you give you the value that you're expected, it's a validated business idea, and after that you can start thinking how to make it on microservices if there's needs for that, because maybe you don't need at all to cut it, to split it.
yeah. So that's actually the core of minimal viable cloud.
Yeah.
Even if you're doing a monolith and it works for your size,
Yeah,
use a monolith.
of course.
Something that's usually neglected is whatever microservices or other distributed systems in general, they come in with a huge overhead of first the cap theorem that says basically you can have partition tolerance, availability, or consistency, but you can only have two of those.
Yeah.
So you at some point when you have a distributed system, you cannot choose the partition tolerance. So basically you say, hey, I'll do microservices. Okay, do you want a available system or a consistent system? Because you cannot have both with microservices.
Yeah, for sure.
And that's the tricky part. There is a great, actually some stories that I heard recently. They're old stories for the first architecture of Amazon and the first architecture of eBay.
Yeah.
So initially actually the second architecture of eBay, but one was actually a DLL that was written in C++, and actually it had like 3.4 million lines of code and classes that had that got the compiler breaking because the Microsoft compiler for C++ at the time only allowed 16K methods per class, and they exceeded that. They had classes with more than 16,000 methods, and that thing worked. And they, on the other hand, an application written in Perl that had that is basically 4 gigabytes of application in a 4 gigabyte address space, and they restarted it every 100, 200 requests, and that was the seed of businesses that are now ubiquitous with success.
So big,
so don't think maybe to conclude our conversation so far, do not try to over-engineer before you need it actually. So that's the whole idea of minimal viable cloud and minimal viability. Try to get your customers straight. Make sure that you know your customers' needs, address those needs, gain customer base, and then try to engineer for scalability once you need it. Because otherwise, many competitors probably of the monolithic startups engineered something complex and they then just died because they couldn't adapt to their customers.
From DevOps perspective, it's the same. I mean, if you are able to provide faster time to market with the KISS principle, let's say, the simplest approach, that it's good. Because, you know, if you move to something very sophisticated or a microservice approach that incorporates a lot of components, the continuous delivery part also will be really hard to be prepared. But why you should start it with that? Start with something small and grow.
Yeah, there is an old saying of every, and I rephrase it here, but every fool can do complexity. Only great engineers can do simplicity.
Yeah.
So try to do simplicity. Okay, so we do, I believe, have some questions. We'll now go through them. So just give me a second. There are quite a few, actually. Question by Fibonacci. How can one proactively align their skill set to meet the current demands of the local Bulgarian market for DevOps and site reliability engineering? So, how can somebody proactively align their skill set to align that skill set to the current demand of the Bulgarian DevOps and SRE job market?
I can say it's not only specific for our market. I mean, it's the same for everywhere. There are any kind of resources if you would like to gain knowledge, continuous improvement for yourself. I don't know. I mean, is it more related to specific courses that you need and technology stacks that you need starting to evaluate and to learn to be competitive, or it depends? I mean,
yeah. And my answer to that is, in the space of information technology, there is almost no such thing as Bulgarian market. So
it is global. I mean,
we are serving usually international markets. So the skills and skill sets that are great for you in whatever, Silicon Valley,
it's the same.
Germany, UK, you name it. The same skill set holds true for engineers in Bulgaria. So it's important to build your skill set. There are great courses. One comes to mind for DevOps that I've watched in the past and currently still. I believe it was Tech World or something with Nana, which is quite a great course on DevOps and goes through, and it's free on YouTube.
For me, not because I am most of my experience is based on Microsoft stack of technologies, but actually now the Microsoft learning course and paths that they introduced in their documentation, it's really great. And there is a lot of hands-on, a lot of theory, a lot of everything what you need.
That is true. Microsoft do have free learning materials and actually videos with basically guys sitting like ourselves and discussing how can you do stuff and actually showing tech demos. I'll move over to the next question because we have quite a lot. It's a question by Yavor. Do you think that if a company already facing challenges in enhancing productivity and maintaining focus on daily DevOps tasks, starts introducing the role of platform engineer, the confusion and disorganization might increase?
No, I don't think, because actually if a dedicated company struggles with the initial implementation of DevOps practices, then firstly that needs to be re-evaluated and to see what are the gaps and what is the issue there, and after that maybe to think to move to the next level, because otherwise it would be a kind of mess.
And my answer to Yavor will be that it's not my answer, actually. I steal it from Eisenhower. So there are two types of problems in life. They're important problems and they're urgent problems. And the trick is not to let the urgent stuff overshadow or take away from the important stuff. So you can consider platform engineering as important in the long run, and the urgent stuff is always gonna happen. There is always gonna be urgent stuff. If you only look at the urgent stuff, you'll never be able to automate the repetitive tasks out of your work. So it's important to set aside or structure your work as such, or convince your product owner or business stakeholder to set aside budget or some time of the DevOps engineers so they can actually provide benefit in the long run and not always be in the position of firefighters taking out the latest fire. Question by Martin Stoyanov. Are you focused on Azure only during your daily work?
Nope. Actually, as a company, we make any kind of cloud native development projects, and also the DevOps that is incorporated inside. Any kind of, actually the three bigger cloud providers: Azure, AWS, GCP. And the most important thing is here that what it means that you're using one cloud provider. Actually, when you're using the cloud provider, you have everything inside from any kind of technologies. I mean,
they're like casinos. They don't want you going looking out on other providers.
I'm using mostly Azure right now, but also I have chance to check some stuffs in AWS to discuss with people in the company some topics or some technical questions, you know. And the truth is that there is a kind of fundamental difference in the cloud providers, like naming conventions or some tooling stuffs. But actually, when you're in there, you can use any kind of open source or not open source tooling landscape, everything.
My take on the question by Martin is there is this notion of convergent evolution. So the cloud providers try to solve pretty much the same problems. And that leads, for example, the hyena's closest relative in the savannah is the lion, not a dog. Although it looks like a dog, but it solves a problems that the best form to solve is a dog. And the same goes for dolphins and sharks, for example. And cloud providers trying to solve the same basically problems in the same problem space come up with the same good solutions that work. Sometimes even they copy each other's features because they're afraid that, hey, we don't have that and our competitors too. So it's mostly the differences between cloud providers is they're calling the same stuff with different names and market it differently, but they're not that different, actually. Another question by Martin Stoyanov. How many approvals do you have to perform change? Do you think about automated approvals? So to approve a change, I believe is the question.
Maybe this is related to our discussion about the self-service portal. One approval is sufficient if it's a kind of baseline service. Of course, it depends of the whole strategy that is implemented. Auto approvals, again, it depends for what kind of service or what kind of architecture it would be related. My opinion is that auto approval is not a good idea, at least until the time when you're sure that the squads, the developer squads, are they have enough knowledge and understanding what they are doing with these possibilities that service catalogs provided for them.
So basically, it's a balancing act between having faster and more lean and more agile delivery, basically without bureaucracy and such,
of course,
and having control over what you're actually provisioning. So it's a balancing act. Do you want faster time to deployment? Do you want more control over what's being deployed? So it's a balancing act, and probably the answer is somewhere along that axis for the companies. Okay, so a clarification by Yavor on his previous question. I mean, do companies which are still struggling to fully adopt and benefit from DevOps practices face additional challenges when they introduce the role of platform engineer? So what are the additional challenges or overhead of having a platform engineering role?
But again, if the initial implementation of DevOps culture is a problem, the same will be overlapping with the platform engineers' problems.
So again, it's an overhead that pays out in the long run. If you just want to ship something for a startup or whatever, and as we know statistically, most startups fail. You might never need platform engineering.
That's why we said that actually maybe it's good to be implemented in companies that have a kind of amount of developers, like 30, 40 or more. And they also adopted earlier DevOps and GitOps, and it's successful, and they have the knowledge to implement and to use the whole tool chain there.
Basically, if your problems and your teams are beyond a certain size, you should consider it. Otherwise, it's not necessarily fruitful for everyone.
It doesn't mean that it will work for you. I mean, it's again with the other discussion that we have.
What works for Google doesn't necessarily work for you. Another question by Martin Stoyanov. Do you use Git as version control system? And based on my previous question, maybe will be much faster to have just QL approval or approvers to approve the commit? So it's a two-part question. First, do you use Git as version?
We use Git in different tool sets because actually, as I said, Azure repos are part of Azure DevOps services, but actually this is Git. Bitbucket also. GitHub also is based on Git. So, and what was the next thing?
The next thing is, and based on my previous question, maybe it will be much faster to use just QL approval or approvers to approve the commit.
But this is based on the branching strategy that is actually chosen. And it's a bit more out of the scope of the platform engineering part.
So basically it depends on how do you do your continuous integration more than how do you do platform engineering? Okay. Another question by Fibonacci. If you're hiring a junior DevOps, which specific qualities and skills are you looking for in a candidate? And how do you assess their potential to contribute effectively to your team?
Of course, we have a kind of way to evaluate the candidate. I'm not saying that it's a kind of checklist, but we have different areas where we actually discuss topics with the person. In most cases, for me, it's important to know and to find that a person is actually able to learn faster and to think, because everything in these days now, everything can be, you can find resources and to learn it and to understand how to implement it and to use it. But if you have the if you want it, I mean, on the other hand, of course, there are some fundamental stuff that everybody as a junior DevOps needs, but it depends of the company. For us, for me, let's say, it's important, of course, to have understanding about cloud providers, but on a high level, because it's a junior one, what is a kind of declarative approach that is provided with infrastructure as a code, containerization stuff, and so on. So I think it's programming, some kind of fundamental understanding of programming,
And also scripting, probably.
Scripting, yeah.
Bash or PowerShell.
Scripting,
or something.
Of course, nothing can be provided without networking. So
basic understanding
of networking, of OCI model, of DNS services, and actually how the web is working. Let's say, but. Of course, it depends of a lot of stuff when you are discussing things with somebody.
Would it be a fair assessment to say that the two most important qualities you're looking is the capacity to learn and the passion for this engineering profession? Okay, so next question. Again by Martin Stoyanov. DevOps, platform engineer. What is the difference?
I think that we discussed that.
Yes.
More or less, it's sometimes it's overlapping. The most big difference maybe is that actually DevOps engineer is involved to the continuous delivery and to deliver any kind of chunk of a code, like a component for something, and the platform engineer providing the platform and the infrastructure part as a self-hosted way to the developers.
Would it be a fair assessment to say that a platform engineer is basically a DevOps engineer that started to automate part of their work, which is repetitive, into internal developer platform?
We can say like this, of course.
So basically one is a subset of the other. So platform engineers are basically DevOps engineers plus some other
also
duties.
Platform engineer can be software developer, software architecture, let's say people that are actually a senior, I mean DevOps, cloud administrator, everything can be.
Another question by Martin Stoyanov. What about hybrid structure, monolithic and microservice? What do you need to know? Knowledge, skills, and tech stack.
So what it means? It's a bit hybrid structure of what?
I believe he wants to say, what about hybrid structure, having a monolith and microservices at the same time?
It's really interesting.
I believe that
having
a monolith and at the same time having microservices is usually kind of a transition state.
Yeah.
Because you cannot just split down the monolith one morning and then go one Monday morning and then have microservices. There are a lot of architectural patterns. Probably the one most used is the Strangler Fig pattern. But the idea is you put something in front of the monolith, you start stripping away basically chunking the monolith into logical chunks. Depends on the business needs, on what's being changed, depends on the business at hand. But basically slicing the monolith in chunks, but one chunk at a time, and basically usually you can use an API gateway in front of the monolith and just reroute some of the requests to some of the newly formed microservices. So having a monolith and a microservice, if you need microservices, you have to go all the way, basically have only microservices, because it's a huge overhead to have a monolith and the microservices. Why the heck do that? Because the monolith...
That was my first impression. That
the only time you need that is when you're transitioning from monolith to microservices. So that's a transitional state for me, and at some point you need to retire the entire monolith. And one additional note, to add more context, you have old software and need to move it to the cloud. Exactly, but cloud is a medium. Don't think of cloud, because you can have microservices on-premise just as well. You can have a Kubernetes cluster and
why not?
Run microservices yourself. So usually it's done while transitioning to cloud, but it's not necessarily so. You can stay on-premise or hybrid and still have microservices, and that's fine. Just a second. Okay, so it seems that those are all of the questions that we received so far. Unless someone doesn't have a last-minute question, I would like to thank you all for participating in today's talk and making it a discussion with you. So thanks again for the attendance. Hopefully it was interesting for you, and you learned something or changed your perspective of something that you have learned. And see you at the next Tech Savvy Talk.
For me,
thanks, Mitko.
For me, it was a pleasure to be here. So to
always
discuss
pleasure to talk to you.
Thank you.